Okay, I'm back. Now we're going to talk about hypothesis development. But before I begin, I want you guys to take a look at this video. It's the same girl from before, the same lady, because this is very useful in understanding the 6 steps to formulate a strong hypothesis.
I'm sure you've heard of the proverb, an apple a day keeps the doctor away. Have you ever wondered if it's true? To test this, we have to formulate a proper hypothesis first. But what is a hypothesis? Hi, I'm Jessica from Scribber, here to help you achieve your academic goals. So, what's a hypothesis? A hypothesis is a tentative statement saying what you expect to find in your research. It's not just a random guess, but a prediction based on existing knowledge. Now we'll grab an apple and munch on it while we dive into this topic. Here are 6 steps to formulate a strong hypothesis. Step 1. Ask a question. Writing a hypothesis begins with a research question that you want to answer. The question should be focused, specific, and researchable. Here I have a question. What are the health benefits of eating an apple a day? Step 2. Do some preliminary research. Your initial answer to the question should be based on what is already known about the topic. Look for theories and previous studies to help you form an educated assumption. For example, you found that apples are nutritious. They're high in vitamin C that can boost your immune system. These are the health benefits that might contribute to fewer doctor's visits. Step 3. Formulate your hypothesis. After you've done your research, write down your initial answer to the question in a clear and concise sentence. For example, daily apple consumption leads to fewer doctor's visits. Step 4. Refine your hypothesis. In this step, you have to make sure the hypothesis is specific and testable. It should also contain the relevant variables, the predicted outcome of the experiment or analysis, and the specific group being studied. So let's set our target group to people who are over 60 years old. Step 5. Phrase your hypothesis in 3 ways. First, we have the if-then form. If people over 60s consume an apple daily, then they will visit the doctor less frequently. The first part of the sentence, daily apple consumption, states the independent variable, which is the cost. The second part states the dependent variable, frequency of doctor's visits, which is the effect. The second way is to phrase the hypothesis in terms of a correlation or effect. For example, daily apple consumption in over 60s will result in a decreased frequency of doctor's visits. The third way of phrasing a hypothesis is by comparing 2 groups. People over 60s who consume an apple daily visit the doctor less frequently than those who don't. Step 6. Write a null hypothesis. Now, if your research involves statistical hypothesis testing, you also need to write a null hypothesis. The null hypothesis assumes there's no effect between the variables. In this case, the null hypothesis is daily apple consumption in over 60s will have no effect on the frequency of doctor's visits. If you want to see more example on how to formulate a hypothesis, check out the article in the description. And that's it on how to write a hypothesis.
Great, so now we can see the different steps in order to write a very strong hypothesis. And we're going to continue. I'm going to tell you a little bit more about hypothesis development. Let me just put this back on. As you guys have seen in this video, you've already done a number of steps because you've already formulated the problem statement, you've already asked the question, and you have already done the literature review. You've already researched past research that has been done on the same topic. And we have also created the theoretical framework. So the next step is to create the hypothesis itself. So it has to be, as said in the video, it has to be testable, a testable statement which predicts your outcome. They are derived from the theory that you have used in order to create your conceptual model, and they're often related in nature. So it has to be logical. It has to be a logical relationship between 2 or more variables expressed in your statement in the form of something that can be testable. So if the pilots are given adequate training to handle mid-air crowded situations, air safety violations will be reduced. The relationships have to be created on the basis of the network of association that we have already created in our theoretical framework. So when we test these hypotheses and confirm the conjectured relationships, we can expect that our solutions will be correct in getting an answer to that problem. So for example, these are different questions and how the hypothesis can be made. So, does a training program in driver safety result in a decline in accident rate? The hypothesis can be people who take a driver safety course will have a lower accident rate than those who do not take the course. Or for example, is there a relationship between education and income? That's the specific question, but the hypothesis is worded saying income increases with years of education. All of these have different variables that have a relationship among them and can be tested. So you have to remember that you have a research hypothesis and it has to be testable. There are different examples here. Exercise leads to weight loss, extroverts are healthier than introverts, but there can be null hypothesis, as you saw in the video, where the outcome is that there is no effect. So exercise is unrelated to weight loss, and extroverts and introverts are just as healthy. Then remember the three types of hypothesis and how you have to format them. The if-then statements. So employees who are more healthy will take sick leave less frequently is changed to if employees are more healthy, then they will take sick leave less frequently. And then there's also directional and non-directional hypotheses, because when we state the relationship between two variables, or when we're comparing two groups, we have to use terms such as positive and negative, more than, less than, if you want it to be a directional hypothesis. For example, the greater the stress experienced on the job, the lower the job satisfaction of employees. Excuse me. This is positive. Women are more motivated than men. These are all directional because it's putting your research in a specific direction. That's why it's called directional. However, non-directional are those that hypothesize a relationship but do not offer any indication of the direction of that relationship. For example, there is a relationship between age and job satisfaction. When we saw in the back, the greater the stress experienced in the job, the lower the job satisfaction. But yet, non-directional does not say anything. It just says that there is a relationship between age and job satisfaction. Or there is a difference between the work ethic values of Americans and work ethic values of Asian employees. These are non-directional. Then when we think of the null or alternate hypotheses, basically it's that there is the variables have no effect, as you can see. So the difference in the means of the two groups is equal to 0 or a definite number that you establish. So it's expressed as no relationship between the two variables or no difference among the two groups. And the alternate hypothesis, which was not covered in the video, is the opposite of the null, where the relationship between the two variables or the difference between the two variables is something different than what you had predicted. For example, drug, null, the new drug has no health benefits, or alternate, the new drug has health benefits. And this is the more scientific approach to creating the hypothesis, the formulas. So the null hypothesis in respect of group differences in our example would be, and the alternate, mean equal to, or mean equal to 0, and the alternate would be statistically less than or greater than. For the non-directional hypotheses, the null hypothesis would be where H represents the null hypothesis and AM is the work ethic of value of Americans and AS is of Asians. And the alternate hypothesis would be like this. Basically changing this, it's not equal to, where H represents the alternate hypothesis and AM and AS are the mean work ethic values of Americans and Asians. And so the null hypothesis is that there is no relationship, there is no effect of for example, this example of the stress experienced on the job and the job satisfaction of employees. And statistically, it would be expressed in this way. And the other one would be an alternate hypothesis, which has been expressed directionally expressed in this way where the correlation is negative. And the alternate hypothesis would be expressed as HA with not equal to. Then there is hypothesis testing, because as you know, the hypothesis statement has to be testable. So in this aspect, you have to state the null and alternate hypothesis as well. Choose the appropriate statistical test, depending on whether the data collected is parametric or non-parametric, and then determine the level of significance desired. Step 4, you have to check that the output results from the computer analysis indicates that the significance level, which you determine in step 3, is met. So for example, if on Excel you haven't had a chance to determine the significance level, then you have to look up the critical values on the appropriate table. And remember that the critical value demarcates the region of rejection from that acceptance of the null hypothesis. And step 5 is if the resultant variable is larger than the critical value, the null hypothesis is rejected and the alternate is accepted. But if the opposite happens, then the null is accepted and the alternate is rejected. Thank you, guys. I hope this has helped you to understand a bit better about the theoretical framework and the hypothesis. I hope to see you very soon. Bye-bye.